Matrices, we can add them, we can subtract them, we can multiply them, but can we divide them? Well, not in the traditional sense. The closest thing we can get to it is finding what we call an inverse matrix. But before we can actually look at finding the inverse of a matrix, we first need to know how to find the determinant of a matrix. So in today's relatively short video, we're going to be looking at finding the determinant of a 2 by 2 matrix. To kick things off, let's have a look at what notation we need to use when we're talking about determinant, and you've actually got a couple of different choices. One of them is to write det in front of a matrix, det, in other words, which is something that's intuitive because det is short for determinant. But the other way you can notate the determinant of a matrix is to use what we call modulus brackets, those straight lines either side of the matrix we're trying to find the determinant of. Now, this isn't the only time you will have come across those modulus signs, or it won't be if you continue studying maths, because it appears in pure maths when applying it to numbers and looking at graphs. It also appears in vectors, and it also in further maths appears when you start looking at complex numbers. Now, we use those modulus brackets in this scenario too because the determinant of a matrix does fulfill a very similar role to those other times the modulus sign does appear, which is the determinant of a matrix is giving you a rough idea of its size. But I am using the word similar very carefully there because unlike the other times when the modulus sign appears as part of maths, you can get a slightly different result when finding the determinant, because normally when the modulus sign appears in maths, the result of the thing you're taking the modulus of cannot be a negative number. Whereas when you're finding the determinant of a matrix, it actually can come out as a negative number. So that's just to make you aware that although the notation is the same as those other areas of pure maths, it is similar, but there is some difference. In terms of what parts of it are the same, well, for instance, if you are taking the product of two matrices, then the modulus of the individual matrices then multiplied together is the same as if you multiply them together, then took the determinant of them, which is also true if you're just looking at ordinary numbers and you just use an ordinary modulus sign applied to those numbers. So that's some of the parts that are similar when we're talking about determinant of a matrix. The other last thing to point out is it's only possible to find the determinant of square matrices. That means matrices that got the same number of rows as columns. So for instance, a 2 by 2 matrix, or a 3 by 3 matrix, or a 4 by 4, etc., etc. Not that you ever actually have to find the determinant of a 4 by 4 matrix and beyond for the sake of the qualifications you are studying. Cool. Right then, so now we know how to notate what the determinant of a matrix is. How do we find the determinant of a 2 by 2 matrix? Well, it's actually quite easy to do. You just need to remember a formula. If you have the matrix A of the structure you can see on the screen right now, then the determinant of that matrix is quite simply A times D take away B times by C. In other words, it's the elements in the main diagonal multiplied by each other, take away the other elements in the other diagonal multiplied by each other. So that's all you got to do if it's a 2 by 2 matrix. There is a different process if it's a bigger matrix than a 2 by 2 matrix, which we'll be saving for another future video. But that's all there really is to it. You've just got to remember that formula because it's not given to you in the formula booklet, but it is just a case of multiplying some numbers and doing a bit of taking away. So let's look at a couple of very quick examples. First one, we want to find the determinant of this matrix. Very easy to do. We've just got to do these numbers multiplied by each other. So that's 3 times by 4, which is 12. And we've got to do these numbers multiplied by each other and then subtract it. So that means we're going to be subtracting 14. And what do you know? This is one of those scenarios I was warning you about where determinants of matrices can actually end up being negative values. Then looking at our second example, also using the other type of notation this time for determinant of a matrix. Again, it's the same process. We're going to do this diagonal, the numbers in that diagonal multiplied by each other. So 8 times by 5 is 40. And then we're going to take away the numbers in this diagonal multiplied together. So that's minus 6 times by 3, which is minus 18. So that means we are going to have to do a minus minus situation this time, and therefore that is going to be 40 plus 18, which is 58. Now, a little tip I would give to you is ultimately, if you're doing this stuff, you can see the calculation is fairly simple. So if people are making mistakes, it's often only a silly mistake, often to do with the minus signs and stuff. So if the second thing you're taking away is a negative, I do bother writing the minus minus, because I find if there's lots of negative numbers involved, trying to do a minus 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 and those sort of situations, that's when people make silly mistakes, because there's just so many minuses all happening at once. And people understand how that stuff works, but it's just trying to have as much of it down on paper as possible, the less you're trying to keep in your head all at once. So therefore I always just multiply the numbers in that first diagonal to get the first number, and then always write a minus sign followed by whatever the numbers in the second diagonal multiply to become, because then I can think about dealing with that minus sign, if it's a minus minus, as a separate stage instead. Okay then, that is find the determinant of a 2 by 2 matrix. Hopefully see you in a future video. Goodbye.